Today's live event was produced for the Connect Transform the Future program in collaboration with National Geographic Education and the Center for Science, made possible through the generous support of GE.
The world's demand for energy is constantly growing. To keep up with that rapid pace of development, energy producers are expanding the use of renewable energy. That means energy that comes from sources that are constantly replenished, like the sun and the wind. As the renewable energy industry grows, so do its career opportunities. Could one of them be the right fit for you and your future career? You just never know, right? Well, we're going to find out a little bit more about that. Hi, everybody. Welcome to Jason Live. I'm Patty Kim, and I'll be your host today as we explore careers in renewable energy. Joining me now in studio is Kathleen O'Brien. She's an electrical engineer, and she also manages GE's Power Systems Laboratory. That sounds kind of cool. We're going to find out a little bit more about Kathleen and her fascinating job in just a minute. But I just want to take this moment to remind you guys out there, we are so excited to have you with us. And this program being live and interactive means that we want to hear from you. So if you guys have questions, please feel free to text them to us and certainly participate in the polls. We're going to ask you guys all kinds of interesting questions. We want to know what you think the right answers are. On that note, we'll toss it over to Kathleen. Thank you so much for joining us.
Oh, thank you very much.
Yeah, we're so happy to have you stop by. You know, I think a lot of people out there find what you do intriguing, but they don't necessarily know exactly what it is. So what is a Power Systems Laboratory? What do you do exactly?
Right, so I, up until very recently, managed a group of people who are engineers and researchers looking into technologies for tomorrow's power grid. So we do from looking how big generators connect to the grid in the classical sense to how you get more wind and more solar integrated into today's electric power grid.
Cool. And when you say power grid, we're talking about possibly one of the largest and most complex machines human beings have ever made, right?
That's right, yes. And so we're talking about everything that it takes in this country and in pretty much every country in the world to bring power from a big generator all the way into your house and let you play video games and use your computer and everything else.
And play with that iPad and all those Angry Birds games.
That's right.
I'm just kidding. The other games are good too, the educational games. Okay, we've got a text question for Kathleen right now. This is from Ashley. What do you do on a normal day at work?
Ah, okay, good question. On a normal day at work, I get to work pretty early in the morning, and I usually spend the first couple of hours talking to my colleagues who are all over the world. So I have colleagues in Bangalore, India, in Shanghai, in China, Brazil, California, Munich, Germany, and usually first thing in the morning I try to catch up with them before they go home for the night. Figure out what's going on, figure out what their day is about, and then I spend the rest of the day usually talking to people from my group or people from other groups related to mine about how to solve problems, what our next challenge is going to be, what some possible solutions to that challenge might be, and figuring out how we can work together to do the next thing we're going to do.
And why is it that you're dealing with people all over the world? Are they involved in the work that's being done in the U.S.? Is that why?
Yeah, so we actually, we do it at GE, at the research center where I work. We have labs all over the world. So a lot of them are focused on technology specific for their power grids. Some of them are focused on technologies that are worldwide. So we really work together as one big global team to to research this stuff. And sometimes, for example, in Germany, where they have a lot of solar on the grid, a lot sooner than they do in the U.S., we get to learn things from our colleagues in other countries because they see problems first. So it's a great opportunity.
Yeah, you're getting a chance to kind of compare systems and learn a few things.
Absolutely.
All right, on that note, we're going to take another text question. This is from Virginia. What source of energy do you mainly focus on?
Oh, okay, good question again. Throughout my career, I've changed jobs a number of times. So up until a few years ago, I was almost exclusively focused on solar power. So specifically looking at how to get large-scale solar power onto the power grid and then obviously deliver that energy to your homes. In more recent years, I shifted to more the traditional generation and wind generation along with solar, and now I'm looking really at all types of energy.
Can you give us the big picture, Kathleen? How popular are renewables today in the United States? I mean, how much of our energy production, energy that we produce here, come from renewables?
So I think right now in the renewable space, we're right around the area of 15% of the energy that we use is produced by renewables. A lot of that is hydroelectric power, so power using water to create electricity behind some of those big dams you've seen. But the contributions from wind and even from solar are growing rapidly.
Okay, next text question for you now. This one is from Lucy. What kind of equipment do you use in your job?
Okay, another great question. So the power grid obviously is huge. If you've ever driven with your family through the big highways, you've seen some very large power lines. Obviously, in my job, in my office, we're not going to bring in, infrastructure of that size to be able to test it. So we use some pretty big, pretty sophisticated computers to be able to simulate what happens in those big power grids. And then we connect those to the computers that run our wind turbines and our solar generators, and we can test and figure out what is the best type of control to have on our products so that we can integrate the power with the grid and bring it to our customer.
Yeah, I guess it'd be pretty hard to bring a giant transformer
Absolutely.
into the office. You got to find ways around that.
Yes.
All right, another text question now, this one from Tina. With the constant changes in technology and new inventions, how do you keep these complex projects up to speed?
So
that's a really good question.
That is very challenging. And, one of the ways we do it, again, is by working with teams of people from all over the world who see this stuff and work with this stuff every day. But it's challenging, and we constantly we're reading, we're talking to our colleagues inside of GE and outside. We are attending conferences, writing papers, talking to colleagues, and trying to be a part of that sort of scholarly environment where everybody is working on the same problems and we're just trying to learn from each other.
All right. Well, we've got some more great stuff to come with Kathleen. We're going to take a poll question right now, or rather, we're going to give you our poll question. So you guys get ready for this one. Which of the following is not considered a renewable energy source? Is it A, wind, B, solar, or maybe it's C, natural gas, or D, geothermal? Which is not considered a renewable energy source? Think about that for a second. We haven't talked a lot today about geothermal. Can you give us a glimpse of how common that is in this country? Do we use a lot of energy that comes from geothermal sources?
That's a good question. I'm not that familiar with geothermal in the U.S. I know in countries like Iceland, for example, where they have a lot of volcanic activity and they have a lot of underground, hot water, that geothermal is a big part of the energy mix. In this country, I'm not all that familiar with it.
I think it's mostly common in the western half, Alaska
Probably, yes.
and Hawaii and places like that. Yeah. So poll results are here, and half of you think that it's natural gas, and that would be
correct.
That would be correct, guys. Great. Natural gas, how popular is that? How much of the energy that we use when we plug in our iPads and our iPhones and our computers?
So, yeah, I'm not sure of the actual percentage today, but certainly in recent years in this country, it's been growing, and a lot of that is due to the fact that the prices have come down, and that makes it attractive to use natural gas. We also obviously still have coal, we have nuclear, and the other traditional types of generation as well.
Do you think renewables will ever become as cheap as fossil fuels to produce?
I think in some places in the country, and certainly in some places in the world, it's already the case, especially with wind. I think that's growing and it's becoming more cost-effective to use renewables, certainly. Yeah.
Right, and if it's cheaper, it'll be possibly more
Right.
common down the road. Okay, more about Kathleen and her fascinating career in just a minute, but right now we wanted to introduce you to some other types of careers in renewable energy. There's more than one, there's plenty. And earlier this year we were able to send a camera crew out into the field to interview some working professionals in the wind industry. You're going to meet a man named Ray right now. He's a GI. Why do I keep seeing GE? GE, wind turbine technician. He does a really, really cool job, and he's going to show us a little bit about what he does and why he does it.
My first thought of him was, wow, that's huge. You know, it's a pretty magnificent, that's for sure. My name's Ray O'Brien. I'm a wind technician here at Stetson Mountain. I'm also the Environmental Health and Safety Coordinator here at the site. A lot of people joke around and say, you know, this is a view from my office, and you know, it is a view from my office. I spend a lot of my time up here. I make sure everybody is up to speed on safety. I do all the harness inspections, making sure the equipment is de-energized and there's nothing electrically or mechanically that can harm us as technicians while we're working on the equipment. And pretty much just make sure everything is going smooth on a day-to-day basis. Well, it's actually an amazing job as far as you're not coming up and doing one thing every day. You know, you're not coming up and just doing electrical work. There's numerous systems in the turbine as far as there's hydraulics, there's the mechanical system as far as the gearbox moving. You do have your AC electricity, you have your DC power, you have communication, whether it's Ethernet or fiber. Every day you're not working on the same piece of equipment over and over, so it's really good in that aspect. Really, the toughest part is dealing with the extremes as far as really cold temperatures. Some days we come out and it's -10, -20, and depending on what the wind speeds are, you know, you're looking at wind chills that are -40, -50, sometimes worse than that. From day one, I've always been the type of guy who likes to tear things apart and put them back together. If something's broken, tear it apart, see how it works, put it back together, make it work again. That's really what drives me as a technician. I love tearing something apart, putting it back together. It's something that I love to do, and that's part of the job. Based on how the oil reserves and fossil fuels and all that's going right now, it's, you know, good to have wind power, and I just see this as being, you know, a start of something big. It seems like it's something that's going to be here for a long time, and I'm hoping it is.
Can you imagine yourself up there?
No.
On top of that wind turbine? Seriously.
It's high.
How tall was that thing?
It's about 100 meters tall.
100 meters, so like a 20-story building?
20 or 30, yeah.
20 or 30-story building. Okay, clearly you cannot have a fear of heights if you do what Ray's doing.
Yeah.
Interesting, he talked a lot about how he just loved taking things apart. Can you trace back your journey to a specific moment or a specific thing? Was there a moment where you went, aha, this is it, I got to go into electrical engineering?
No, for me, not really. It was more of a gradual unfolding of what I thought would become my career path. So I was not as interested as a kid in taking things apart and putting them back together and making them work. I was more interested in figuring out why the machine was created in a certain way and not in another way, and why we're building something and not another thing. And that sort of led me to, you know, through a lot of different twists and turns to where I am now.
Right, and so it wasn't like a specific moment, you sort of had to kind of wind your way to where you are. Tell me a little bit about your education, like what kinds of things did you study through high school, into college, that landed you here?
Yeah, so I through high school I studied, I think, just traditionally what kids study in high school. I didn't have a one particular focus, certainly. I was very interested in social studies, in reading and English, and also in math and science. And then I went to college and I sort of decided almost on a whim to give engineering a try, and figured out I was pretty good at it. And then I started studying, obviously, you know, physics and electric circuits and power, and slowly narrowed into more of just, looking at power and how that's used electrically.
And you studied some of that in German as well, right? Because you
That is
studied
true.
at a university in Dresden, right?
Yes, in Germany, yes.
Wow. So you had to pick up the German pretty quickly.
I tried, yes.
Not all of you will have to learn German to become an electrical engineer.
Certainly not. But it helps.
As you're proud. Okay, we've got a video question for you now, and this one comes to us from Hannah and Olivia.
Hi, I'm Hannah. And I'm Olivia. We're from St. Philomena School in Peoria, Illinois, and we were wondering, why did you choose to be a power systems engineer?
Okay. Again, for me, it wasn't really one moment of deciding. I think I worked in a couple different fields of electrical engineering before I got here. At one point, I was working on nuclear submarines. And then I really started to get excited about the largeness of the power grid and the impact that it has on everybody's lives. And I had my own kids, and I was interested in their future and how they're going to use energy. And it just got more interesting and more exciting as time went on, and then I ended up focusing in that area.
All right. Well, we've got another text question for you. Ready for this one?
Sure.
This one is from Hunter. How did you become interested in renewable energy in the first place?
Great question. Again, I was an electrical engineer. I was working on sort of how you translate energy and move it around in a ship or a small system. And it was interesting, but it wasn't, I knew it wasn't the end. I knew it wasn't the final thing I wanted to do. And my, I had friends in the area. I had people I knew that were interested in the space, and I was listening to them talk and explain what they did. And it got more and more interesting to me, more exciting, and I ended up in that area.
But you didn't go into fossil fuels. You could have gone electrical engineering into fossil fuels, and you went into renewables. That's interesting. Yeah.
It's interesting. I mean, you see the potential it has to change the way we do things, and it's so exciting when you think about it from, it's a revolution in an area really that hasn't had a lot of revolutions. So
it's kind of a new frontier.
Right. The power grid has looked a lot. It hasn't fundamentally changed a lot at least in my lifetime. Right. But this is really a revolutionary change.
So now you're on the cutting edge. Okay, we've got, well, you are in some respects. We've got a video question now from Matthew.
My name is Matthew, and I'm from St. Philomena School in Peoria, Illinois, and I was wondering, what experiences did you have that contributed to you wanting to have this career?
Okay, good. There was a lot of experiences, especially meeting people who were in the space, seeing their passion and excitement for it, doing things that were sort of adjacent to it or close to it, and then realizing that I'm pretty good at it and I could also do this other thing that maybe could be more impactful or more exciting. And certainly, obviously, having, again, my own children, my own family, and seeing that I want to make a better world for them.
What quality would you say is really important to have for the kind of job that you do? A lot of people probably thinking out there, oh, you got to be really good at math, and you got to know your facts, and you got to be this and that. Is there any quality that most people don't realize that would be really handy to have in this field?
I think maybe, I don't know, the ability to deal with situations where you're actually not able to use your math to find one clear answer, but maybe all the variables are shifting and moving, and you have to use your judgment and be okay with the fact that maybe there isn't one clear answer. And then obviously the ability to explain your solution to another person, to work together in a group, to come to a consensus those are all pretty important.
So communication is really
Absolutely.
important. Did you have any misconceptions about it going in? Did you think that it was going to be a certain way, and did it surprise you?
itself?
The career itself?
Yeah, I suppose I did. I think when I was in college, and certainly when I was in high school, I thought that this career would be very, me alone in a room with a pencil or a computer doing math.
Or a giant chalkboard where you just had equations written all over.
Yes, and certainly that happens at times, and it has happened at times in my career. But for the most part, that's not at all what it is. It's very interactive. It's very creative. It's not, solving a prescribed problem. It's really coming up with creative solutions to new problems no one's ever seen before.
All right, time now for our poll question. This is for you guys out there, so think about this one. This has to do with Kathleen and her personal history. When Kathleen was 12, she dreamt of pursuing this career when she grew up. A, lawyer. B, historian. C, astronaut. D, nurse. Well, you have dropped a few hints since we've been talking about what you're interested in. Does she sound like she wanted to be a nurse at one point? Does anybody have any feeling out there? Astronaut. I could actually see you in space. And I mean that in a good way. I mean, that would take certainly a special skill set. You know what? I am getting word from our control room that the astronaut is in lead for the answer, with historian in second place. Wow, so I wasn't totally off the mark. A lot of you thought astronaut. What's the correct answer?
Historian.
Historian. Yes. Historian of any period in particular?
Oh, anything in the Middle Ages was very interesting to me in that time period in my life.
Middle Ages, okay.
Yeah, see Europe, that kind of thing. But it sounds very different than my job right now, but I think really for me looking at why and how things unfolded and evolved the way that they did historically lets me sort of imagine how things will be in the future and think about technologies I could use to get us there. So it really is.
So it's a little more connected than we think.
Than it might seem on the surface. Yeah.
All right, well, it's time now to check out a couple more career profiles. This time we're heading up to northern Maine. We're going to go right back up there and meet Troy and Bill. And then we're also going to meet Dave and Jacob, and they help manage and operate a wind park there called First Wind. And we're going to find out exactly what they do there. Take a look.
At Stetson site, we have 55 1.5 GE SLE turbines, and they span over a ridge that is approximately 4.5 miles long. With 2 people keeping the place running, it takes a lot of man hours, and we're busy the whole time that we're here. My name is Troy Cameron, and my role here at First Wind is Assistant Operations Manager.
We work in an industry that's got electrical, it's got mechanical, it's got hydraulics. There's so many things that you can do in this industry. Tomorrow you'll be doing something different. My name is William Hare. I'm the Operation Manager for all the main sites.
As an Assistant Operations Manager, I oversee the day-to-day site operations. It is a lot of different things that we have to do. We have to be safety conscious, we have to be environmentalists, we have to be supervisors, accountants, good with equipment, we have to be mechanics, electricians. It is a lot of responsibility. There are a lot of things that can happen day to day.
You don't have to sit in an office every day. If you tomorrow want to go out and do some road work with Troy, I can go out and do some road work. I think that's why people really like the wind industry. Clean energy industry, I can only see it getting bigger.
The more renewable energy we have and the resources that we have, the better off the environment is going to be in the future.
My name is David Grant, and here at the Stetson Wind Farm, I'm a wind farm support specialist.
My name is Jacob Terrio, and I work at the Marcel Wind Farm as a wind farm support specialist. Being a wind farm support specialist, your responsibility is taking care of all the site vehicles, the maintenance records, the maintenance logs.
We do everything from snow plowing on the roads to repairing the roads to inspecting the high voltage facilities, cleaning the building, repairing the building, maintaining the building. We do maintenance on the site. We inspect the roads and maintain them. We do some work in the turbines, which is basically usually inspection work.
I would say my favorite thing to do is climbing turbines. That never gets old. And you walk in and you got your harness on, you got your hard hat on, and your safety glasses and your gloves, and then once you get up and you can look around and stand up, words can't describe.
When the wind farm is operating, the turbines produce electricity which is sent out to the substation. In the substation there's a variety of transformers, breakers and relays which we monitor for any kind of damage, any kind of misoperations, to make sure they're maintained in an operating state. So at any point in time, if there's any problems with the lines, we can open and close those circuits to stop the flow of electricity in or out of the park. My favorite part about working here is that I actually get to spend approximately half my time doing office-type paperwork, but I also get to go outside and do about half my time in the outdoors, which I'm a big outdoorsman. I've always loved being outdoors and working outside.
Working on a wind farm, you can expect anything to happen. You gotta be up for anything. You come in the morning and you got a turbine down and you're needed to go climb. And so you could have a plan in your head and it could be changed really quick.
Boy, do they ever wear a lot of hats, don't they? And I don't mean construction hats, literal hats. I mean, wow, you got to be a mechanic, electrician, a supervisor, an accountant, and all sorts of other things. It's kind of it's kind of daunting, but I guess if you're interested in having a mix of things to do in your job, that would be great, huh?
I think so, and also there's a lot of careers in renewables that are even outside of that space. So there are people who write about renewable energy, there's people who make art about renewable energy, there's people who plan, finance, design. There's tons of different careers in this space, even outside of engineering.
Wow, it's not just what those four men are doing that exists. You have lots of options, people.
Yes.
Lots of options. We're going to go to our first video question for this segment. This comes to us from Grace.
Hi, I'm Grace from St. Philomena School in Peoria, Illinois, and I was wondering, how will wind technology revolutionize how we will live in 10 years?
Oh,
okay.
That's a pretty big word, revolutionize.
Yes. So I think in 10 years, hopefully we have more wind out there. People see it. They know what it's there for. They know how it's going to integrate into the energy mix of the country as a whole, or even other countries. There's more intelligence in the wind turbine. There's more communication between the wind turbines themselves. It's becoming more efficient. I think, it's unlikely that wind energy is going to revolutionize the way we live, but hopefully it will allow us to use power in a much more efficient way. It'll bring awareness to people about power and energy efficiency, and hopefully it lets us ultimately burn less fossil fuel to earn the same amount of energy in our home.
All right, awareness is so important, isn't it? Okay, we're going to take a text question right now. And this one is from Kaylee. She'd like to know, in what ways are we exposed to renewable energy in our day-to-day lives?
Okay. Well, depending on where you live, you could be using power from renewable energy right now. In some regions, California, in Iowa, in Texas, certainly, wind, for example, is a big part of the energy mix. So you can be exposed to it without really even knowing you are. In other places, there's a lot of people who are putting solar panels on their roof and they're saving on their energy bill. It really depends who you are, where you are, and really how you choose to look around and notice the renewables in your area.
I'm wondering, are the sunniest and the windiest places in the U.S., is that where we would find the solar panels and the wind farms? Is that how it works? Is there a correlation right?
Absolutely,
like
although there are sometimes financial incentives to put them in places where it's not that sunny or not that windy. But in general, you can say yes. An exception to that would be the whole country of Germany, which has developed through government incentives a huge solar industry. They're not really very sunny, at least not relative to, say, Arizona or a lot of the U.S.
But they're still taking advantage of the technology of solar panels.
Absolutely.
Something we can learn from
Absolutely.
down the road? Okay.
Yes.
A text question for you now, Kathleen. This one's from Dominic. I notice a lot of bridges in the United States are rusted and in need of constant repair. What do you think will happen to the wind farms out in the ocean? How will they be maintained? That's such a good question.
That's a good question.
Very good observation.
So right now, the places where there's a lot of offshore wind are places like Northern Europe, for example. Not that much in the U.S. So it really depends on country to country how we decide to do that. But in general, the people who own the wind farm make money by selling power. if the wind farm is not maintained and it starts to fall apart and it can't deliver power, the people who own that aren't going to be making money. So in general, people have an incentive to keep that repaired and keep it up, which unfortunately, you know, unlike a bridge, which is publicly owned, that sometimes doesn't happen. But in general, we would rely on the owner of that wind farm to maintain it.
You know, this might be sort of asking you to look in your crystal ball, and I don't know if you feel like you have a crystal ball, but you know, when the car was invented, of course, the gas industry sprang up out of that, because we all need gas for our cars. Do you foresee any specific invention or event that would sort of spark the need for more energy and maybe more renewables in our energy production?
Oh, that's a good question. I don't know. I mean, I think if, you know, unlike the gas automobile example, right? What we do today, we can use energy from fossil fuels the same way we use energy from wind. If that example was to hold, we would need to find a type of load or thing that uses energy that needs specifically renewables. I haven't thought about that. I don't know. It's a good question for the students out there to think about.
It's a big question. Okay, we've got a question for you now. It's our poll question, and this one is about wind energy. Let's take a look. In 2012, wind energy was the fastest growing source of power in the United States, accounting for a certain percentage of new generation capacity. Was that percentage A, 13%, B, 23%, C, 43%, or D, 73%? First of all, for people out there who might be going, what is new generation capacity? What's the easiest way to explain that?
Okay, so if you're talking about new generation capacity, you're talking about new types of generators, so a new coal plant or a new nuclear plant or a new solar farm, wind farm that was connected to the grid. So once you build it, you hook it up and you start delivering power. In the year that you hook it up and start delivering power, it's added as new generation capacity. So we're talking about the generation that was connected to the power grid in the last year.
All right, okay. Well, that clears up that problem. We've got the results in, and Pat, do you want to tell me again? 50-50, okay. A lot of you, half of you in fact, picked 13%, and the other half picked 23%. But the correct answer is 43%. Wow, that's impressive.
Right, so even though we see that renewables today are not that big of a high of a percent of the total generation on the grid.
Right, it's a tiny slice of that big pie.
Absolutely, but last year of all the new generation we added, a huge percentage of that was renewable, so you can see how it has a potential to grow.
Wow, okay, well we look forward to seeing more of that, more wind farms going up. Right now we're going to take a look at another career profile. This time we're heading up to Boston, Massachusetts, where we meet two gentlemen. One is named Matt, the other one Pavan, and they work at First Wind's Distributed Asset Control Center. Let's find out what that is. Take a look.
I would say an exciting day in the DAC is what we like when there's a lot of wind. My name is Matt Forrest. I'm the DAC manager here, and DAC is Distributed Asset Control Center.
Distributed Asset Control Center, and that's the eyes and ears of the company. My name is Pavan Kumar Dhavaleshwar, and I work as a senior DAC operator. And what we do here is control and monitor wind farms all over US.
We run 16 wind turbine sites with 540 turbines, almost a gigawatt of electricity. In the control center here, we have our monitoring screens that the DAC operators use to maintain an overview of 540 individual generators. They're looking at turbines on a real-time basis. We can help predict what's going to happen with a turbine. The DAC operators make a lot of decisions to determine what is safe and what is not safe, and they coordinate with the site operations teams and the site turbine managers to make the right decisions on a daily basis.
We have control capability. We can shut down the whole fleet at one click. We can shut down the turbines.
We can operate the components in the substation and coordinate with the utilities and the balancing authorities that run the electrical grid to make sure our electricity goes out into the grid without a problem. It's a very complex job that requires your brain to be engaged full time. It's more than just turning a switch. It's asking yourself, what's going to happen if I turn the switch and I don't get the expected response? what are 3 or 4 likely scenarios that are going to could possibly happen besides the turbine starting up correctly, and what am I going to do for each one of those? Those kind of things have to be going through the operator's head every single time they start a piece of equipment.
It's pretty fast paced. We tend to feel overwhelmed and try to get panicked, but we have got used to it. And coming from the background I come from, I really enjoy that part rather than sitting idle. That really comes from good time management skills, multitasking, end of the day getting the things done in a safe, secure manner, and in a manner which really impacts the company in a positive way.
When I was in high school, I didn't know that I was going to end up doing anything with power generation. I kind of knew I liked physics and math, calculus, whatever it was, anything to do with engineering, mechanics. I like to build stuff. I like to do hands-on things.
And I really like this industry once I got into it, mainly because of the value it adds to the environment, it adds to the society. And once I started getting more involved into it, I really started liking it. It's because it's always changing. So there's something new you can add every day.
Turbine, tomato, how do you say it?
Turbine.
Turbine, you say turbine too?
I do.
Okay, you've got the New England pronunciation. I think I say turbine. That was really cool to see.
Yes.
It's kind of amazing to think that they control or they have to oversee that many turbines or turbines.
Absolutely.
Let's take it back to you guys. You guys have more questions for Kathleen. This one comes to us from Brett. Does the size of the turbine affect the speed of the turbine and the amount of power it gives? Does the size of the turbine affect the speed of the turbine?
So when we're talking about speed, there's a couple different ways you can talk about it, but if you're talking about the speed, one of the ways we talk about it is by talking about the speed at the very tip of the blade. So in some cases, yes, the bigger diameter you have, then the more power you can get through it. So I forget exactly what he asked, the speed and the...
Does the speed of it, does the size of the turbine affect the speed of the turbine?
So when you talk about the size, you talk about the total swept area, which basically is the circle that is made by the tips of the blades as they go around. The power that you get out of it is directly proportional to that area. So a lot of times, some of the work that's done at the research center where I work, which is not my work, but the work of others, is to try to extend the length of the blades so that you can take the same tower and get more power out of it.
And by the way, some of those blades span the length of an entire football field.
Absolutely.
So that's how big they are. Another text question for you, Kathleen. This one from WHS Environmental Science, 12th grade Environmental Science at Woodridge High School. Approximately how long would it take a community to recover the cost of constructing a wind turbine in saved electrical energy?
Okay, so that question depends very, very much on where you are, how much obviously it costs to construct the turbine, and all sorts of costs of labor and other things that are very variable, and also obviously in how much wind is available at that location, how constant the wind blows.
Can you give us a range?
I think I've heard some numbers out of Ireland that are in the range of 10 to 15 years.
10 to 15 years, and you start to recoup. Okay.
Right.
We're going to go to another text question now. We've got a lot of them coming in. Thank you, guys. We're really happy to hear from you. How do you compare renewable energy versus energy that can only be used once? So I guess Kathleen is referring to energy that comes from a fossil fuel.
Right. I mean, there's a whole lot of different ways to make that comparison. One of the ways that that it's different, I guess, is if you're burning coal, you are 100% devoted to making sure as much of the energy that is in the coal as possible gets converted to energy on the power grid. When you're looking at a renewable, such as solar, for example, you don't care particularly much about the efficiency of a single solar panel, those rectangular shaped panels you see that collect the power from the sun. You care more about overall, how much energy can I get out of the sun versus how much does it cost me to produce this, to put it out there, to maintain the land.
Right.
So it's a different target, so to speak.
Right.
About,
and when you're talking about solar panels, you're saying, so you've got this rectangular shaped solar panel,
right.
the sunlight hits it,
right.
and maybe only 14, 15%
exactly
gets changed into electricity that we can use.
Exactly. But if I even have to lower that to 12%, but I can make it a lot more cheaply and I can get it out there a lot more, and maybe I can make it with less harmful materials, or any advantage I can get, it might be better for me to go with the less efficient
So it really depends.
option.
Okay, one more text question for Kathleen. Ms. Randolph would like to know, why would somebody go into your line of work?
Oh, okay. Oh, there is a lot of different reasons, and there are a lot of people in this line of work that all have very different reasons. Some people like, to be outside. Some people like it because it's impactful to the, energy mix. Some people like it because they're making a better sustainable future. Many, many reasons. For me, I think I really enjoy the people I work with, and I really like the fact that I can do something that is positive for the future.
Well, on that note, I want to thank everybody who joined us today. Believe it or not, we've run out of time. Thank you so much, Kathleen, for sharing your story, a little bit about your world. It is truly fascinating. Because this is the future, right?
Yeah, absolutely.
This is the future, and it's so great that you guys all jumped in with your questions, great, insightful questions. Do you have any final words of advice before we go? Do you want to leave them with anything?
I would just say that, as I said, there's a lot of different people in this area, and there's a lot of different jobs and opportunities. If anybody's interested in hearing from more scientists and more engineers, even outside of the renewable space, that work in the research center where I work, you can go to our blog that's called Edison's Desk, and you can read about a whole lot of different people that have chosen careers in science and engineering and math, and get more information about why they did what they did.
Yeah, and if you have an inkling that you are passionate about energy, about science, this field, you can definitely check out Transform, Connect the Future. It's a project on the National Geographic Education website, and you can see the website address is right there, natgeoed.org/connect. Once you get there, you're going to find a ton of free online resources designed for kids from grades 4 through 12 to help you think about energy in different ways, maybe ways you haven't thought about before. Energy solutions, certainly things that we need to think about today and for the future. Also, that's a really cool game that you saw there. It's called Planet Green, The Big Switch. So you want to check that out too. Not just Angry Birds. There's lots of other cool games out there too. For everybody here at Jason Live, I'm Patty Kim along with Kathleen O'Brien. Thank you so much for joining us, and we'll see you next time. Bye-bye.
Bye-bye.